Right, so today we're going to be talking about functions. Now a function is basically just something that converts an input to an output. So you could imagine it almost as some kind of black box where you feed it one number, let's call that A, and it chucks out a different number B. So an example of a function in x, and the notation for that is f of x, could be something like x squared. So if now instead of having a black box we put x squared in there, you should be able to see that if we put in a number, say 3, that function would give us an output of 9. Now there's a bit of terminology we need to know around functions and how they work. So the first two of these are the domain and the range. So what do we mean by these two words? Well, the domain is basically the set of possible input values to the function. And what we mean by that is what values can we put into the function in order to get out a real output. So an example of that might be if we did square root of x, you should be able to see that we wouldn't be able to put in negative values of x here because that would give us a solution which isn't real. Now if the domain is the set of possible input values, the range is the set of possible output values. And just as there are certain inputs we can't put into a function, there are also certain outputs we'd never be able to get out of a function. So an example of this might be something like x squared, and you should be able to see that we'd never be able to put in a number into this, real, positive or negative, that would give us a value which was less than 0. So x squared is always greater than 0. So only the real numbers bigger than 0 make up our set of possible output values of this function. I often find it useful to illustrate functions using a graph, and we can kind of highlight what the domain and the range are on here as well. So if we take that example above of x squared, we can see that if you were to blow up this graph a bit, the input values would range from negative infinity to positive infinity. So our domain, in effect, is negative infinity to positive infinity. But as we said, we could only ever get out positive values from squaring a number. So our range is f of x is greater than 0. So this is f of x here on your y-axis, if you like, and this is x on your x-axis. And you can see the domain and the range on the graph because our line is only ever found in the positive region of f of x. We could also think about what would happen, for example, if we constricted our domain. So let's say we only input values from x is 2 to x is 4. Well, that would only output values from 4 to 16. So if we constrict our domain from 2 to 4, we can only have a range of 4 to 16. So that was an example of where we had a domain in which any real number could be input to the function, but we could only get positive real numbers out of the function. But we could also have examples where our domain was more constricted. So, for example, if we did square root of x, that looks something like this. Well, in this case, you can see our domain is only ever the positive values of x. So our domain is x is greater than 0, and our range, again in this case, is that f of x has to be greater than 0. And we can see that because our output values are only ever greater than 0. Now the last piece of terminology we can talk about is what's known as the roots of a function. And this is in effect quite simple. All we mean by the roots of a function is the values of x, in this case if it were a function of x, but if it were a function of y it would be the values of y, but it's the values of x for which our function f of x is equal to 0. So again, graphically, if you were to think about that, that would just be the points where if you had some kind of function, it would be the points where it's intersected the x-axis. Because at this point, you can see your value of f of x would be 0. And so sometimes you might be asked to find the roots of a function. Well, that also isn't too tricky. So if we had a function, for example, x squared plus 5x plus 6, and we were asked to find the roots of that function, well, we know the roots are found where f of x is equal to 0, so we'd set x squared plus 5x plus 6 equal to 0, and now it's just a case of solving a quadratic in this case. So we could factorize this into x plus 2, x plus 3, as they're two things that multiply to 6 and add to 5. And you should be able to see then we would have two roots of x is minus 2 and x is minus 3. And we could see that graphically again as well. So if we had f of x against x, we'd have some kind of curve which went through -2 and -3 to look something like that.